I'll be presenting an OJT report, the development of Course Code's coding platform. First, I'll give a brief introduction. So this OJT project is done for Mapua under the supervision of Engineer Annalyn Newmang. Digital learning is now the go-to platform for conducting classes. We need to maximize students' learnings through digital learning tools. This project is mainly for students taking up C++ programming courses. Dedicated environments for students learning to code in C++ and practice together with an automated solution verification for instructors are lacking. As such, a web application that would help facilitate digital learning for students in terms of programming was created. It's a platform where instructors can provide programming-related assignments to students. Students are provided with a dedicated environment to write, compile, and run code without relying on external tools or services. So for the technical learnings, the trainee was familiarized with full-stack development, learned to create an application using React for the UI, and Redux for state management. As for the backend, the trainee learned .NET Core API and PostgreSQL with Entity Framework Core for object relational mapping. Docker containers were used with async processes in C# to develop a service for running programs in an isolated environment. Services built was configured in a multi-container environment to help ease deployment. The Google Cloud Platform was used to host a virtual machine and the Nginx reverse proxy to proxy requests and serve content. Each of these components were successfully designed, developed, and integrated to build the final application. Discussion of the assigned project or proposal. So the background of the opportunity, the platform is aimed at providing a dedicated digital environment for students to practice solving complex engineering problems through programming. It provides instructors an automated way of tracking students' progress in solving programming problems. Use of digital learning materials are widely adopted in Mapua University. Most tools offer digital delivery of content through lecture materials and examinations. So the present situation is programming problems assigned to the students are answered on their local machine. When students submit their code, the instructor's methods for checking is to run each of the students' submission and check if the results are valid. So the manual method for checking the validity of student submissions can be a burden. So the development of the platform will allow automated checking for student solutions. The developed tool will be used by Engineer Annalyn Newmang and her students for CPE 103L courses, which are courses that teach C++ programming. So for the system requirements, you only need a desktop or laptop with stable internet connection and an up-to-date browser. For the boundary conditions, a built-in code editor is used. Compile and run functionality can be used in the web application, and the application is only limited to C++ programs. So the alternatives to the solution is a custom-made web application, HackerRank code screen or code pair, and test for geeks. The two previous alternatives are less cost-effective since it requires a license to be used. The chosen alternative was a custom-made web application because it allows full control of the application and is more cost-effective because of free online credits for hosting. So for the development of the project proposal or preferred activities, first is the project process flowchart. The project planning was done initially before the development of any application. The back-end API was developed, then the front-end application, and the configuration of container services. All of these applications and services were integrated and tested until the application works as intended. If it works as intended, then the application is deployed. Next is the use case diagram. Instructors can create courses, generate join codes, and create assignments. Students can join courses, use the code editor, and submit solutions. Both of the users can view their profiles, view their courses, view students' lists, view assignments, and view solutions. The entity relationship diagram shows all the tables that are used in the database and their corresponding columns. For the software architecture, the API, database, and web application are contained in a multi-container configuration using Docker. They sit on an Ubuntu virtual machine with an Nginx reverse proxy handling requests from users over the internet. It exposes port 80, which is HTTP, for users to access. Next is the Gantt chart. The project took a total of 7 weeks to complete, from planning to development to integration, testing, and deployment. Next is the execution of the project. Here are some screenshots for the web application. This is the landing page where users are directed initially. Users can sign up as a student or an instructor, and they can sign in as well. So for the students, the main functionality of this application is the built-in code editor. It is used by the students to write, compile, and run code in the web application. A problem is displayed for the user to solve. Their solution must pass the test cases expected output in order for them to submit their solution. Once the assignment is solved, a success message will appear indicating that they can now submit their solution.